All right, guys, how you doing? This is 2.4, the chain rule, part 2. So, we saw yesterday the chain rule in general, and we know that this undoes composition of functions. But today I'm going to do it slightly different. Instead of inside and outside, I'm going to use what's called a U substitution. Okay, so notice how it's sine of U, tangent of U, secant of U. We want to let U be our 4x. It's like we're saying let U be the inside. Then the derivative of U is just 4, right? So what we've done now is we've rewritten this as y equals the cosecant of U. Well, we know the derivative of the cosecant of U is negative cosecant U cotangent U times the derivative of U. And we could do a simple reverse of our substitution. That's cosecant of 4x times cotangent of 4x. And we don't have to worry about that inside outside. And you could do the same thing with the algebraic functions instead of the trigonometric functions like I'm showing you here. But this might help a little bit with some of the problems on the homework. Wow. Language is hard this morning. Okay, so remember this sine squared. This is 1/4 sine of 2x all squared, right? So check this out. I'm going to let U be 2x, and then the derivative of U is 2. So I've rewritten this as a 1/4 the sine of U all squared. See, but now I'm going to have an inside is sine of U, and my outside is something squared. My derivative of n, the derivative of sine of U, is cosine of U times du. And the derivative of the outside is 2 times something to the first power. Let's move our cursor down here, give us a little more space. So, this du, let's see if we can put this all together. Now the 1/4 is a coefficient. It comes along for the ride, right? 1/4 times the function, so we're going to have 1/4 times the derivative. Now what is the derivative? The derivative is the derivative of the outside. Leave the inside alone. Multiply by the derivative of the inside. And we can reinterpret this in terms of U and du. 1/4 times 2, that's 1/2. Sine of 2x cosine 2x times 2. And you'll want to simplify this 1/2 and 2 to get sine of 2x cosine of 2x. Simplify when it makes your entry of your answer easier. Simplify when it's just screaming at you and you can't not simplify. And simplify when the instructions say to simplify. Otherwise, simplify it if you're going to have to use it. All right, now this is the same idea, right? Instead of sine squared, now it's sine cubed. So let's rewrite that. This is sine of 4t all cubed. So we'll let U be 4t. The derivative of U is 4. So we're now looking at the sine of U to the third power, where our inside is the sine of U. The derivative of the inside is the cosine of U, a du. Don't forget that du. Derivative of the inside. My outside is to the third power. And the derivative of the outside is 3 something squared. Looks like we need more space again. Putting these all together with our u substitutions. Remember, anytime you're doing algebra, or calculus in this case, you'll want to absolutely keep it as organized as possible. Keep a system so that you always know where you're going with things, or where they're going to come from. So my derivative is the derivative of the outside. Leave the inside alone. And then multiply by the derivative of the inside. Now we're going to replace all of our u's, right? This is f prime of t, but I have a u and a du, so we replace those. So the derivative is 3 times sine squared of 4t times the cosine of 4t times 4. I really want to multiply that 3 and 4 and make it 12, but I really don't want to have to write that over again. So that's one of those where I would absolutely put 12 and then the rest, and not have the 3 times 4 looking all weird like that. All right, let's keep going with these. Part 2 is all trig all the time. Okay, so every time I do this, right, every time I take it slow, the inside of the trig function, I'm going to let that be u. My derivative, I find that with, so I'm only looking at this little bit, u equals 3x. My derivative of u, I only look at that 3x. I don't worry about the rest of it. Now, what we've done is we've rewritten this, so it's 5 tangent of 3x. No, we haven't. Erasers are amazing. I wish I had one in the classroom. 5 tangent of u. So our derivative, 5 hangs out, right? 5 multiplies the function, so 5 multiplies the derivative. The derivative of tangent. The derivative of tangent is a secant squared of u du, right? Tangent of u, if we scroll up to the first page, the derivative of the tangent of u is secant squared u du, and then we put in our 3x times 3, and I'm going to make this one look better because it's less writing. All right, 15 secant squared of 3x. All right. Oh, how you doing? I know I'm cruising through these because you guys don't have time to ask questions. Because I'm recording. But remember, this inside outside, that's just trig rule. That's inside outside, that's chain rule. Chain rule, you know how to do chain rule. We did so many chain rules in class on Wednesday. And it's a simple little inside substitution to deal with the trig first to get it into a u form so that it looks exactly like our rules. All right. So this is very similar. Very similar. Here we go. So I'll let u be 5t. I'll let du be 5, right, because t is our variable, so the derivative is 5. I'm now looking at the cosine of u all squared. This little squared notation that we use for trig functions is super handy, so we know that it's not the 5t that's squared. We don't have to use parentheses. It's just a little easier for us to read and to write in general. But just like a radical is nice for square root functions, it's easier to do the calculus on it if we use old school notation. So for the radical, we use the rational exponents. And instead of the fancy cosine squared of 5t notation, it's easier if you write it as a cosine of u and then all squared, because then you can see that we have a chain rule. So never forget where these notations come from and what it's shorthand for. So the derivative of cosine is a co-function, so it's negative. Cosine and sine stick together. So the derivative of the inside is minus sine of u du. Our outside is something squared. So the derivative of the outside is 2 times something. And our derivative is g prime of t is the derivative of the outside. Leave the inside alone. Multiply by the derivative of the inside. And then we make sure, since this is g prime of t, we reverse our u substitutions and take it back to t. So 2 cosine of 5t times minus sine of 5t times 5. I don't like that at all. So I'm going to write it better. And this negative sign in the middle of it all easily turns into subtraction when it should be multiplication. So we have a minus 5 and a 2. So g prime of t is a negative 10. All right, the 5, the negative, the 2. Cosine of 5t, sine of 5t. Just because it's easier to enter, sometimes simplification is just a good idea. Algebraically, it could get to be a nightmare, but trigonometrically, it just makes it easier to enter or to understand your answer. And we're going to have to simplify eventually, so we might as well get used to it. All right. Oh, do you need me to scroll back up? No, go back and use pause, people. Just kidding. All right. If I don't crack a joke or be weird, then you won't know that it's actually me recording it. Okay. Inside of the sign, u is 3 pi x. Remember, pi is just a number. Yeah, it's a symbol. It's a symbol for a number. So the derivative, what's the coefficient of x? The coefficient of x is this whole 3 pi. So all of 3 pi is the derivative of 3 pi x. So now my derivative, all right, this is the sine of u. Derivative of the sine is the cosine of u du. Reverse our substitution. This is the cosine of 3 pi x times 3 pi. And frequently, when it comes to trig functions, I like to rewrite it so my coefficient is literally in the front. That 3 pi can easily just kind of work its way inside those parentheses if you aren't crazy, no, if you aren't careful. And so I like to make sure that I get it separated by that cost so that I know that it's not part of the argument of the cosine function. Ooh, check this out. Oh my goodness, good problem. Okay, what's my inside? My inside happens to be pi t minus 1 all squared. Right? That's 3 secant of u. My du, I have to use the chain rule. So it's not on the trig function itself where I'm using the chain rule, it's my inside substitution. So inside is pi t minus 1. Outside is squared. Derivative of the inside is pi. Derivative of the outside is 2. So the derivative of u is derivative of the outside, leave the inside alone, times the derivative of the inside. I'm gonna tighten that up a little bit. I'm gonna call that 2 pi times pi t minus 1. I don't think multiplying it through will be helpful at all. Multiplying that 2 pi through. So I'm going to leave it in factored form. Now we know that the derivative of 3 times secant of u will be 3 times the derivative of secant of u. The derivative of secant is a secant u tangent of u. times du. All right. F prime of t is 3 secant of pi t minus 1 squared tangent of pi t minus 1 squared times, I ran out of room, I can't believe I did that, times the derivative of the inside, so times 2 pi times pi t minus 1. Derivative of the inside. Oh yeah, that squared, huh? Okay, I'm cool with that. So, put this all together. Let's simplify it a little bit. Nobody wants to have to type that if you're using a homework system like I do for my students. Gotta have room just in case. Putting this all together, making it look pretty. F prime of t should be 6 pi. All right, the 3 and the 2 pi makes 6 pi times pi t minus 1 secant of pi t minus 1 squared tangent of pi t minus 1 all squared. And it came from something simple like 3 secant of pi t minus 1 all squared. And you just made this look really hard. But you did something that's really helpful. But people look at that, they're like, wow, you're a genius. And you just nod your head and say, yes. Yes, I am. All right, so do you remember when I asked in class, hey, you want to see one of these problems that just nests and goes on forever? I know you probably said, no, it's all right. We're going to do it anyway. And we're going to need more paper. Yes, half a page, not enough. Okay. Let's first turn this into a function, or even just a y equals type of function. All right, so I'm going to use colors here. I'm going to use colors. So first of all, I'm going to let u be the square root of the cotangent of 3 pi x, so that we have y equals the sine of u. And we know that y prime, the derivative of the sine, is the cosine of u du. All right. Well, the u is no problem. We got that handled. We need to find the derivative of u. Now, in order to find the derivative of u, I'm going to use purple here. I'm going to do a chain rule again, kind of. I'm going to use, what comes next? V. I'm going to use V equals, I'm going to make this a little bigger though. V equals the cotangent of 3 pi x. I don't want to use V. I'm sorry. I don't want to use V because I'm not doing the trig part yet. So I don't want to use these letters. I want to use inside. It's the cotangent of 3 pi x. And the outside is the square root, which we know as the 1/2 power. The derivative of the inside is going to need another chain rule. The derivative of the outside is 1/2 to the negative 1/2, right? Subtract 1 from our exponent. But in order to find the cotangent of 3 pi x, use another color. I guess we'll go with blue. In order to find the derivative of the cotangent of 3 pi x, I'm going to let V be 3 pi x, and then dV is 3 pi. Meanwhile, I'm looking at a little f equals, not f of t, not function notation, just horrible notation, a cotangent of V. So its derivative of cotangent is cosecant squared u du, and that's a negative. Oh, that should be a V, right? A V. because that's the variable I'm using. Yeah, I'm going to leave it ugly. I'm not even going to erase when I could. All right, I'm going to erase. I'll erase it all. Excuse me. So we're going to work our way back up here. To find the derivative of cotangent of 3 pi x, we know that will be negative cosecant squared of 3 pi x times 3 pi. So, the derivative of the square root of the cotangent of 3 pi x, the derivative of this u, that's what we're looking for. I'm using a chain rule. And that chain rule, go back to black now. No, I'm not going back to black. The derivative is this. All right. It's the derivative of the outside. Leave the inside alone. Multiply by the derivative of the inside. Yeah? Yeah. And this is, I don't know why I changed that to purple. That should be blue. This is where I get the 3 pi x. This is where I get the 3 pi coming all together. But we're still not done. No, this is such a good problem. Here's what we got. Remember, we have our y prime, right? Going back to the original function. And I just found du. That's all this is. I just found du. Delightful. So my derivative is the cosine of u, so cosine of the square root of the cotangent of 3 pi x times du. So times, I'm going to have that 1/2 and the 3 pi and the negative all out in front. So 3 pi over 2 with the negative cosecant squared of 3 pi x. This is in the denominator because it's a negative exponent, square root of cotangent of 3 pi x. Now remember, even though it's super tempting, let me make that bigger, super tempting to cancel this 3 pi x, remember cotangent's got it messed up. And we can't cancel this cotangent of 3 pi x with square root of cotangent of 3 pi x with this square root of cotangent of 3 pi x because cosine has this one messed up. So the 3 pi x's can't cancel because they're inside of other functions and those other functions are doing things to them. And this radical can't cancel because the radical out front is inside of the cosine. So if you need to remind yourself that it's inside somewhere and not just hanging out like an algebraic factor, put the parentheses around it. Oh yeah, that's a cosine. This is a fantastic answer. I'm going to leave it like that. All right. Fun times with trigonometric chain rule. You got this. I swear you could totally do it. And I'll be there Monday through Wednesday answering questions completely. And on Thursday, maybe not at all. We'll see. We'll talk. That's it for this episode of Math with Tuesday. No, I'm just kidding. Have a great day. I'm recording a new lecture very soon.